Perhaps the most famous trait of tardigrades is their incredible resilience. They can survive harsh conditions that would destroy almost any other animal. However, it's important to note that tardigrades are not extremophiles that thrive in these extreme environments. Rather, they endure these conditions temporarily and will perish if exposed for too long. The key to their resilience lies in their ability to enter the tun state, a form of cryptobiosis. In this state, tardigrades shut down their metabolism, drying out and halting all cellular processes. Essentially, they enter a deep, dormant state and stop needing food or water. Some species can remain in this state for years or even decades and still be revived when conditions improve. The longest observed time in the tun state was over 30 years, though the longer they stay in this state, the harder it becomes for them to recover. This state allows them to endure extreme conditions. Tardigrades can survive temperatures as low as negative 272 degrees Celsius, which is close to absolute zero, and as high as 149 degrees Celsius or 300 Fahrenheit, but only for short periods. They are also highly resistant to desiccation, able to survive severe water loss by entering the tun state and rehydrating when water becomes available again. During their tun state, tardigrades can survive without oxygen, endure pressures as high as 600 megapascals, about 6 times the pressure at the bottom of the Mariana Trench, and thrive in zero-pressure environments. They are also remarkably resilient to radiation, able to survive levels that would be fatal to almost any other organism. In 2007, researchers took tardigrades into space and exposed them to the vacuum of space for 10 days. 68% of them survived and were able to reproduce afterward. Later studies showed that their survival was due to their tun state. Hydrated tardigrades had much lower survival rates. Some species have additional survival strategies. For example, Halobiotis crispae, a marine tardigrade, switches between a summer morph that reproduces and a winter morph that doesn't. The winter morph is highly resistant to freezing and low salinity, helping the tardigrade survive harsher conditions. While not a true tun state, this behavior is comparable to hibernation. Tardigrades can even survive impacts of up to 1200 Gs. To put that into perspective, 1 G is the force of gravity we experience on Earth. In a car crash, forces of 30 to 50 Gs are typical,